In this problem, we are told that an IQ test is designed so that the mean is 100 and the standard deviation is 23 for the population of normal adults. We want to find the sample size necessary to estimate the mean IQ score of statistics students such that it can be said with 90% confidence that the sample mean is within 6 IQ points of the true mean. So we're assuming that sigma is 23. So I'm going to write that down. And we want 90% confidence. And we want to be within 6 IQ points of the true mean. So that means that our margin of error should be 6. The formula for this is n is equal to z sub alpha over 2 times sigma divided by the margin of error, and then we square that whole thing. In your textbook, they square each of those values individually, which is fine to do it that way, or you can do it this way. That comes out the same way either way. Okay, so I want to start with finding z sub alpha over 2. If we are going to want 90% confidence, that means that 90% should be the middle of our normal distribution. And that means that there's 10% left over for each of these tails. So, and I should say it's 10% for the two tails combined. So there's going to be 5% for the top tail and 5% for the bottom tail. So what I'm looking for here, when we say z sub alpha over 2, in this particular case, that's z sub 0.05. So we took the 10% left over and divided it by 2. So the 10% is alpha. We divide by 2, we get 5%. So to find z sub 0.05 in the calculator, I'm going to use inverse norm. And I'm going to say what percentage falls below that score. So whatever score z sub 0.05 is, there's 95% that falls below there. So I'm going to put in 0.95. And then I can say the mean is 0 and the standard deviation is 1. Because we're looking for a z-score, we're not looking for a score in terms of the problem. So when I put that in, I get 1.645. So this you're going to want to round to 3 places. Normally we round to 2 for this, but in this particular case, when we're doing z sub 0.05, and we get 1.645, we're going to go out 3 places in order to calculate the answer they're going to give you on MyMathLab. So if you look on the formula sheet that I posted on Canvas, then you'll see the 1.645 goes out to 3 places, and also 2.575. You're gonna, if you get that value, you're gonna take that out to 3 places. So I have 1.645 times 23, divide by 6, and then square this. And when I do that in the calculator, I get 39.76 something, something, something. I really don't care what the decimal part is because we're always going to go up to the next integer when we're finding sample size, so we go up to 40. So in this case, I would have rounded to 40, But if it had been 39.0011, I'd still say 40, because we have to go up to the next integer. So it's not a rounding thing. It's making sure that you get the minimum sample size needed, and 39 is not quite enough. So we have to go up to 40. So that's how you get that answer.